There we go. Now it's starting. There we go. I always hate the beginning, so we've already started. We're going to talk about measuring energy, and I'm going to pull this up. Oh, wrong mouse. Okay, so there we go. We're going to cover these items, and we'll get to this shortly here. But with measuring energy, you're going to be using the wind, the turbine, the tower here. What is this part called? Foundation. Nacelle or nacelle, yeah. Do we have to worry about any of this? No, because that's all taken care of. What you will be dealing with will be up here in the drive shaft. This is the drive shaft. And then on the other end, we'll put the drive shaft through the nacelle, whichever way. And then there's a little green plug that goes on the end so it doesn't slide off. And this is what your setup will basically look like. You are going to take care of the rotor, the hub, and the blades. Your research should have been on shape of blades, how big, angle that they're at, that sort of stuff. Once you put your hub with your blades on here, we'll come back and cover this in a minute. We'll have a fan, and we're going to go with the fan at 1 meter from, I'm off the screen, close enough, 1 meter from the rotor, okay? So then when the fan is on, the air is going to hit your blade, and what's it going to do to the blade? It's going to push it out of the way, right? So you're going to take kinetic energy out of the wind, move it, change it to mechanical energy when it pushes the blade and moves your rotor, your hub, which will move the drive shaft, which will spin the dowel, the spool at the end. And on the end of the spool will be the cup. We'll leave that down there. And so as it spins, it will lift the cup. You're going to time the time it takes for the cup to go from the table up to a given height. And then you'll stop the clock. Okay? So that'll be your distance. Now, remember your objective, your design problem is that you have to produce a rotor, blades and hub, that will take the most power out of the wind and lift the cup with the masses in it, the weights in it. Okay? So, if the cup's too light, it'll go very fast, but you won't be doing any work, and your time will be small, but your work will be small too. So you have two small numbers in a fraction. We'll cover all that when we do the equations next week. Okay, so that's your general setup. Yep?
Would you want a small number because it's the fast side?
You want the small time, but you want a larger numerator. Okay, you want a larger work output. Okay, so, well, how does this all work? We've got blades. These are supplied. We know how many. I just need to know how many we have. I need to know how many groups we have, and from there I can divide it out and tell you the maximum number of blades each team will get. We have 1 box of blades for each hour. The first blade, and unfortunately it's not showing up very well on here. We'll get it bigger and see if it works better. Balsa wood. This is balsa wood. And balsa wood is $15. Now remember, that's just a number for us to work with. Okay? Balsa wood is $15, and it is 3 inches wide. But are we using inches? No, we're using centimeters. And it is 7.5 centimeters wide. It's 12 inches long, which comes out to be, should be 30. Oh, this is a little bit over. So this is 30.5 centimeters. 30.5 centimeters. by 7.5 centimeters. Okay. Yep. You sure can. But when you buy it, you buy this. That's a great question, because if you cut part of this off, you still had to buy this whole thing, and this is just called waste. But you still had to buy it, so that comes into your overall cost, right? Yep. What I said? 30.5 centimeters long, and by 7.5 centimeters wide. Okay. 3 inches by 12 inches. Okay. This would be $15. Cardboard, same size. They're the same size. Okay. Cardboard, we said, would be $10. Okay. That'd be $10. You know those yard signs during election time, or vote yes for this, vote no for that, whatever? They're corrugated cardboard, but they're made of plastic. Corrugated cardboard is the cardboard that has the two sides and then the wave in between. Those plastic ones, if you have that and you want to use it, awesome. Feel free to bring it in. But every piece that you use that's the same size, we would count as $30. Okay, we would count that as $30. Yep. You sure can. Thank you for bringing that up. Other materials that you bring in, feel free to bring in other materials. We'll figure out a cost somewhere in there between that $10, maybe $5. If you bring something in that might work better than the plastic signs, then it might be more than $30, but we'll go from there. Okay? Feel free to bring anything, just about anything. Remember, no metal. No metal, no sharp edges that could really cut things. Okay? To cut these to shape, we have several items. We've got a small hacksaw, and we have case cutters or utility knives. Safety deal is whoever signs the blade out is responsible for it. They are the one to use it. You sign it out, you bring it back. Okay? Always, always pull towards you. Always have as little of the blade out as you need. If you're going to cut through this, which is only about an eighth of an inch thick, you don't need the blade out 1.5 inches. Okay? So it's just a little bit. Balsa, this blade, it's just a case cutter or a utility knife. There's different names for the same thing. So this part you buy. The dowels you have to buy. This one is a smaller dowel. This one is 5 inches, which comes out to be 13 centimeters. 13 centimeters. There are longer ones also. I don't have one with me right now, so we have to measure those. The short dowels are $5. The long ones are $10. Yep. You're just going to keep track of your numbers. Yeah, we're not going to trade the money thing. It's just too much for right now. Okay. It would work well, but okay. To attach the dowels to the blades, we have hot glue guns. Okay. Once again, safety issue with that. The little metal tip at the end, don't touch it. It's hot. Okay. It will burn you. Okay. So don't do that. The glue that's coming off the end and is melting is hot. Don't touch it. Okay. We also have white glue, you know, the old-fashioned like Elmer's, but it's just a different brand. You can glue them on. We have tape. You can tape them on. Those attachment things, as long as you're not using gallons of glue or 50 glue sticks, it's just on the free side. Okay? So that's where we have. The next part that you need is the hub. Like it showed you before, the hub will attach on this end. When Kidwin started this stuff, they used Tinker Toys. Anybody remember Tinker Toys? Okay, those little wooden wheels that had all the little holes in them. They had a little bit bigger dowel than this one, but that's what they used. Okay, well then they upped the ante and they made these hubs. I'll see if there it goes. You can see it in the video. And these hubs have bigger holes. So this is like version 2.0, right? So the hubs work like this. there is a wing nut on the outside. You loosen that up, there we go. And then the front and the back can pull apart. You put your dowel inside, tighten the wing nut up, and it tightens on there. Now, this is the skinny dowel, so it does not fit in there, but if you had the bigger dowel, it would clamp down on it. And then you would take and put it up into the hub. We're going to avoid using the blue ones because I'm not sure we have the connectors anymore. We might be out of connectors to put them in, okay? Version 3.0, the black ones. The black ones. These, they amped it up even more. There are, I should tell you, with the blue ones, there are 6 holes for you to use. The black ones, there are 12, so you could put 12 blades on here. Okay? And they are smaller, so when you loosen up the front, pull them apart, use a small dowel, you put it in, and then tighten it up, and then it holds on. Okay? The back of the hub goes on to the green connector there. You have to make sure it's in far enough, otherwise it'll fall right off. Okay? Wind comes and hits the blade, turns it around and around and around, lifting the cup. Yep. I think we'll use high. I think that's what we used last year. We might have to adjust the distance and stuff because it might lift it too slow or too fast. So I believe it was high and 1 meter that we used last year. Okay? And we'll figure out a spot in the room to set that up. So far, so good. Short dowels, $5, long ones, 10. We bring other materials in, we'll figure out the cost. Balsa wood, 15, cardboard, 10. The signs, however much you use, and that'd be for this size, okay? Yep, 30 for that. One thing to talk about here, and I'm going to be leaning forward so you can see it on the video better. We also have a protractor, because if the blade is sitting like this, yep. Well, that's a good point, because if we put it like this and it's square, okay, and it's at 0 degrees to the hub, the wind hits it, and is it going to go anywhere? No. You have to turn it a little bit, don't you? Because then when the wind hits it, it's going to push the blade out of the way. Well, how much do you turn it and how do you measure it? We have these handy dandy little protractors. And what you literally do is you have to set it on the side of the hub, and you can either go from the back or the front. I prefer going from the back so that it does not hit the wings on the wing nut. And then when you put it on here, I'll lean forward here, so you have it at 0, and then if you twist the blade, you can read the protractor. My thumb's in the way on the video, but you can read the protractor. Here, I'll turn it this way. And you can tell the angle that you have it at. Do you think the angle is going to make a difference? Wonder if the blade is like this. So then, from the front, it would look like this. Yeah, it'll go past. So you need to figure out what angle works the best. So your research should be dealing with angle, shape, because as it's going this way, is this long edge very efficient for cutting through the air that's over here in the way? No. So that's why they have these different shapes. And you saw lots of different shapes on there. Okay? I think we've covered more than we did first hour. And we're at 14 minutes, so I'm going to hit the